Imagine standing beneath a velvet night sky, your eyes tracing the familiar outline of Orion, the hunter, etched in stars. Among them, one glows with an eerie reddish hue, pulsating like a cosmic heartbeat. This is Betelgeuse, a star that has captivated humanity for centuries, its name whispered in ancient texts and modern observatories alike. A celestial giant, it looms large in both the Orion constellation and our collective imagination, a red supergiant teetering on the edge of a cataclysmic fate. Renowned physicist Brian Cox has recently stirred the world with a warning. Betelgeuse, this luminous titan, may be on the verge of a supernova explosion, a cosmic spectacle that could light up our skies and rewrite our understanding of the universe. But what does this mean? Are we on the brink of witnessing a stellar catastrophe, or is this merely the latest chapter in the star's enigmatic story? Let's embark on a journey through the cosmos to unravel the mysteries of Betelgeuse, explore the warnings of its impending doom, and discover what this giant red star reveals about the life and death of stars. Betelgeuse, perched on Orion's left shoulder, is no ordinary star. It's a behemoth, a red supergiant that dwarfs our sun in both size and grandeur. If you could place it at the center of our solar system, its fiery surface would swallow Mercury, Venus, Earth, and Mars, stretching out to nearly the orbit of Jupiter. Its surface, cooler than the sun's at roughly 3,500 Kelvin, casts a reddish glow, a stark contrast to the sun's 5,500 Kelvin radiance. This cooler temperature, combined with its immense size, gives Betelgeuse its distinctive crimson hue, a color that has fascinated observers since antiquity. Ancient Chinese and Roman texts, dating back some 2,000 years, described it as yellow, a clue to its evolutionary journey. By the 9th century, Arabic scholars noted its fiery red appearance, a testament to its transformation over millennia. This shift in color isn't just a curiosity, it's a window into the star's life cycle, a story of growth, change, and eventual decline. Stars like Betelgeuse are born in fiery crucibles, forged from clouds of gas and dust in the vastness of space. About 8 to 8.5 million years ago, Betelgeuse ignited, a hot, blue star burning with youthful vigor. Over millions of years, it consumed its hydrogen fuel, undergoing nuclear fusion that fused hydrogen into helium in its core. As the hydrogen dwindled, the star entered its twilight phase, expanding and cooling into the red supergiant we see today. This phase, known as the supergiant stage, marks the culmination of its evolution. Gravity and nuclear fusion have sculpted Betelgeuse into a star of staggering proportions, its mass estimated to be 15 to 20 times that of our Sun. This immense mass sets the stage for its ultimate fate, a supernova, a cataclysmic explosion that will mark the end of its life and scatter its elements across the cosmos. What makes Betelgeuse so captivating is not just its size or color, but its unpredictability. Unlike most stars, which shine with steady regularity, Betelgeuse is a semi-variable star, its brightness waxing and waning in cycles that defy strict patterns. Astronomers have documented a primary cycle of about 400 days, with a longer, more mysterious cycle spanning roughly 5 years. These fluctuations have been observed since at least 1836, when Sir John Herschel meticulously recorded the star's behavior, though Aboriginal oral traditions may hint at even earlier observations. The star's luminosity pulses like a cosmic metronome, sometimes bright enough to rival the brightest objects in the night sky, other times dimming to a faint glow. This variability has long intrigued stargazers, but in 2019, Betelgeuse did something extraordinary, something that sent shockwaves through the astronomical community and sparked whispers of its impending doom. In late 2019, Betelgeuse began to fade dramatically, an event now known as the Great Dimming. By February 2020, it had lost brightness at a rate of about zero point 0.1 magnitude per day, reaching its lowest recorded luminosity. To the naked eye, even in light-polluted cities, the star appeared noticeably fainter, a ghostly shadow of its usual brilliance. This wasn't just a minor dip in brightness. It was a cosmic anomaly that left astronomers scrambling for answers. Was this the prelude to a supernova, the final gasp of a dying star? Or was something else at play, a quirk of Betelgeuse's complex nature? The world watched, telescopes turned skyward, as scientists raced to decipher the star's cryptic message. To understand the Great Dimming, we must delve into the heart of Betelgeuse's turbulent surface. Unlike our Sun, which appears serene from afar, Betelgeuse is a roiling cauldron of plasma, its surface churned by massive convection cells. These cells, driven by the star's intense internal heat, create turbulent flows that can eject material into space. Observations from the Hubble Space Telescope, sensitive to ultraviolet light, revealed intricate details about these processes. The telescope's data showed that during the Great Dimming, Betelgeuse had expelled a colossal plume of hot material from its surface. This material, a plasma hotter than anything on Earth, erupted from a convection cell, soared into space, and cooled as it traveled. As the temperature dropped, the plasma condensed into a vast dust cloud, a cosmic veil that shrouded the star and blocked a portion of its light from reaching Earth. The scale of this event was staggering. The ejected material was estimated to weigh about 400 billion times the mass of a typical solar mass ejection, more than the mass of Earth's moon. This wasn't a routine occurrence, it was a dramatic upheaval, a sign that Betelgeuse is in an unstable phase of its life. The dust cloud, formed from the cooled plasma, settled on the star's outer layers, dimming its brilliance and creating the illusion of a fading star. The Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile provided ultra-high-resolution images of this event, capturing the expansive gas plume and the star's mottled surface. These observations confirm that the Great Dimming was not a sign of an imminent supernova, but rather a natural, albeit rare, process in the life of a red supergiant. Yet the Great Dimming was only part of the story. Betelgeuse's surface is marked by star spots, vast regions where the magnetic field is thousands of times stronger than the Sun's. These spots, larger than Earth and covering up to 20% of the star's surface, create cooler areas that reduce its brightness. The magnetic fields trap gases in looping arcs, forming zones of intense activity that contribute to the star's variability. During dimming cycles, roughly every 430 days, these star spots become more pronounced, adding to the star's enigmatic behavior. The interplay of convection, magnetic activity, and mass ejections paints a picture of a star in constant flux, its surface a battleground of cosmic forces. The light we see from Betelgeuse today is a snapshot of its past, a message sent 400 to 600 years ago, depending on its precise distance from Earth. This time delay complicates our understanding, as the star we observe may have already undergone dramatic changes. The James Webb Space Telescope, with its unprecedented ability to peer into the infrared spectrum, has offered new insights into Betelgeuse's recent behavior. In recent years, it detected evidence of a massive eruption that stripped away a significant portion of the star's visible surface, releasing clouds of dust that further hint at its turbulent state. These eruptions, while not uncommon for dying stars, are extraordinary in their scale and frequency, suggesting that Betelgeuse is nearing the end of its life cycle. Brian Cox's warnings about Betelgeuse center on this very instability. He has described the star as a ticking time bomb, a celestial giant poised to explode in a supernova that could outshine the entire Milky Way. When that moment comes, Betelgeuse will collapse under its own gravity, its core compressing until it triggers a cataclysmic explosion. The resulting supernova will scatter heavy elements, carbon, oxygen, iron, across the cosmos, seeding the raw materials for new stars and planets. For weeks or even months, it could shine as brightly as a half moon, visible even in daylight, a spectacle unlike anything modern humanity has witnessed. Cox emphasizes that this event could happen within our lifetime, though the exact timing remains uncertain, potentially occurring tomorrow or in tens of thousands of years. The prospect of a supernova raises questions about its impact on Earth. At its distance, Betelgeuse poses no direct threat. The intense radiation from a supernova, including gamma rays and cosmic rays, would dissipate over the vast distance, leaving Earth's atmosphere and magnetic field unscathed. Unlike a closer supernova, which could disrupt the ozone layer or trigger mass extinctions, Betelgeuse's explosion would be a visual marvel, not a catastrophe. Scientists estimate that only a supernova within 50 light-years could pose a significant risk, and Betelgeuse is far beyond that threshold. Instead, its explosion would offer a rare opportunity to study the death of a massive star, providing data on stellar evolution, nuclear fusion, and the cosmic recycling of matter. Betelgeuse's dynamic nature extends beyond its surface. As it moves through space at roughly 67,000 miles per hour, it carves a path through the interstellar medium, creating a bow shock, a wave of compressed gas and dust akin to the wake of a ship. This phenomenon, visible in infrared images, highlights the star's interaction with its cosmic environment. The bow shock is a testament to Betelgeuse's restless energy, a reminder that even as it nears its end, it remains a force of nature, shaping the space around it. This interaction provides clues about the star's mass loss, a process that accelerates as it approaches its supernova phase. The material it sheds will one day enrich the interstellar medium, contributing to the birth of new stars and planets. The scientific community remains divided on the timeline of Betelgeuse's fate. Some speculate that its recent behavior, mass ejections, irregular pulsations, and dimming cycles, suggests an imminent explosion. Others caution that these are natural processes for a red supergiant, and the supernova could be thousands of years away. Hydrodynamic simulations, like those studied by researchers at the Massachusetts Institute of Technology, suggest a link between Betelgeuse's convective activity, mass ejections, and pulsation changes. These pulsations, driven by the star's internal energy, dissipate through shock heating, contributing to its instability. Yet, the presence of a possible companion star hinted at in some studies could stabilize Betelgeuse, delaying its final act. This uncertainty only deepens the star's allure, as scientists and stargazers alike await its next move. The cultural impact of Betelgeuse cannot be overstated. Its name, derived from the Arabic Yad al-Jawza, meaning hand of the giant, reflects its prominence in ancient astronomy. From Greek astronomers like Claudius Ptolemy to Aboriginal storytellers, Betelgeuse has inspired awe and wonder across cultures. Its recent dimming sparked a flurry of excitement on social media, with posts on platforms like X amplifying both scientific curiosity and sensational speculation. Media outlets have occasionally exaggerated the imminent threat, but astronomers, including Cox, have worked to temper these claims, emphasizing the beauty and scientific value of the event over fear. As we gaze at Betelgeuse, we're reminded of our place in the cosmos. This star, born millions of years before humanity, is a living chronicle of the universe's history. Its eventual supernova will be a bridge between past and future, a moment when the elements forged in its core become the building blocks of new worlds. Whether it happens in our lifetime or far beyond, Betelgeuse's story is a testament to the universe's grandeur, a tale of creation, transformation, and rebirth, written in light and fire across the night sky.